Hi, my name is dr. Ahmath. In this video lecture, we're going to discuss the complete square form of the quadratic functions. So we are going to discuss what is this complete square form. We are going to discuss how to bring a general quadratic function into this complete square form. And also we're going to also discuss why we actually need this complete square form. So let me remind you that previously we defined the quadratic function as f of x or y is equal to the ax squared plus bx plus c. So this is also called as the general equation of quadratic functions. So for example, I can give you the examples of the quadratic functions as 2x squared plus 8x minus 64, or y can be equal to the minus x squared plus 68, all the examples of the quadratic functions in general form. So this is the general form, this is the general form. So if you remember our previous lectures, I wrote down sometimes the function like x minus 3 in the square plus 4, for example, right? So, and I told you that this is also a quadratic function. So we can bring this into this general form by just opening the brackets. So if I open the brackets, it's going to be x squared minus 6x plus 9 plus 4, which is going to be x squared minus 6x plus 13. Okay, so you see, so this is the general form of the quadratic function. So we brought this from so-called complete square form. Complete square form. And it was more or less easy and straightforward. What I would like to learn is how to bring a general form into this one. So basically, if you're given this kind of quadratic function or this kind of quadratic function, how to write them in this form. So first of all, let's define the notation of the complete square form. So we said that a quadratic function in the form of y is equal to the a times x minus h in the square plus k is the complete square form. Complete square form. So please note that this a here is the same as this one. So we can see this from this example here as well. So if you remember, a here is equal to the 1. And if you bring this as a general form, you've got again a, which is like coefficients of the x squared, is again 1. It's the same number. Okay, so a, the coefficient of the x squared, in the complete square form and in the general form are going to be the same. So before learning how to bring the equations into this form, I would like to remind you a couple of formulas of the complete squares. So we've got this formula, x plus a in the square. It can be expanded as x squared plus 2a, oh, so let me write this as 2x times a plus a in a square, right? So any complete square form which is in the form of x plus a or x minus a, it always comes in a form like a x squared, then 2x times to some constant. Then this constant in the square. So, or at the same time, x minus a in the square can be written as x squared minus 2x times a plus the a squared. Okay, so again, the structure of this complete square when we just open all the brackets is always coming like the first term x squared always, then 2x always times to some constant and plus this constant in the square. So let's try solve like how we can do this. So let's say you are given the general form. Okay, so let's do this general form. So x squared plus 4x plus 4. So if I would like to bring this into the complete square form, I need to use again the structure, right? So the structure tells me that, hey, it should be in a form like a x squared plus 2x always, right? then this side of this equation should be the same as this side, okay? So I have 4x on the left-hand side, so that is why I have to multiply this to the 2, right? So you see here in the formula, so after 2x, I need to multiply the 2x to some constant, and after this term, right immediately after this term, it comes this constant square, right? Which is 4 in this case, okay? So x squared plus 2x plus multiplied to the 2 plus 4. So if this side is the same as this one, then I can write as a, it's going to be x plus 2 in the square, right? So x plus this constant, which comes after 2x in the square, okay? So what if I don't have here plus 4? So let's say I'm given the term like x squared plus 4x. Is it possible to bring this to this complete square form? So that means yes, we can try to do this. So I'm going to do this in this way. So I'm going to write down this again. So x squared, oh, let us change it. So let's make it 6x, okay? So let's make it different. So we're given x squared plus 6x. So what is going to be the next term just after the x squared? It's always coming either plus 2x or either minus 2x, okay? So since it is like a plus here, so I'm going to write this as a plus 2x, okay? So I have to multiply this to some constant, right? So that it's going to be equal to the 6x because I don't want to change the equation, right? So the left-hand side should be always equal to the right-hand side. Then I'm going to write this as a 3, right? And if you remember the formula here, so a constant which is multiplied to the 2x, just after that term, it comes its square, the square of that constant. So here, the constant is 3, or basically a is 3. Then just after this, it should come 3 in the square. Okay, so the reason why I added the 3 in the square, because this term, the 3 terms, can be written as the square, complete square. So as the x plus 3 in the square. Okay, so the problem is that this equation is not the same as this one, since we added this term artificially to here, right? So the 3 in a square has been added artificially in order to make this complete square, okay? But if I would like to keep this equation to be equal, the left-hand side to be equal to the right-hand side, I need to keep it a balance, right? So I need to subtract this 9, so, or 3 in a square. If I added the 3 in a square, I have to subtract the 3 in a square as well. So in order to keep this equation balanced, to be equal, okay? So this part is a complete square part, so minus 9. So I can write this down as x plus 3 in the square minus 9, okay? So this is the general form, again. So this is the complete square form. Complete square form. So let's do a couple of more examples. So let's say you are given x squared plus 7x, okay, plus 14. 7x plus 14. Again, the general idea is going to be always the same. So you need to write down x squared plus 2x, always, okay? Then I have to multiply this to some constant. So in this case, this constant is going to be 7 over 2, right? So because this should be equal to the 7x. Then just after this term, it should come at its square, right? So 7 over 2 in the square in order to make this term to be the complete square, complete. So since I added 7 over 2 in the square, because which is not present here, I have to subtract this. So in order to make this equation, in order to have this equation, so it's going to be 7 over 2 in the square, right? So this is going to be just canceled. I'm just adding 7 over 2, so that's why I'm subtracting this. And additionally, I used to have 14 plus 14 in the left-hand side. I have to just have this here as well, okay? So please note that this side of this equation is the same as this side. The left-hand side is equal to the right-hand side. So I'm just like rewriting the terms in a slightly different form in order to have the complete square part, okay? So it is going to be written as x plus 7 over 2 in the square minus 49 over 4 plus 14, right? So let me give the common denominator and calculate things up there. So it's going to be 4 times 14, it's going to be 56 minus 49, it's 7, right? So it's going to be x plus 7 over 2 in the square plus 7 over 4, okay? So if you remember, we said that the like a quadratic function in the complete square form is going to be written as a times x minus h in the square plus k, right? So for this form, what are going to be the parameters for this parabola or for this parabola? So the a is equal to the 1. So the a is equal to the 1. K is equal to the 7/4, and h is equal to the minus 7/2. Okay, so we need to be able to bring a general quadratic function into this form always. Okay, so there is a reason why we need this. So let's do a couple of more examples. So let's say you are given like a y is equal to the, say what if you have some constant in the x squared, for example, minus 2x squared plus 8x, let's say, minus 72. Okay, so first of all, which I would like to do is I would like to take out minus 2 out of the brackets because I know how to work with the x squared part, but we didn't have this constant before the x squared before, right? If you just take out the minus 2 from the brackets, what we have here is x squared minus 4x, right? So minus 72 stays here. Okay, so this is kind of a general form of a quadratic function, and we can bring this to the complete square form, right? So let's do this like in separately. So let's say you are given x squared minus 4x, and I would like to bring this into this general form. So it's going to be written as x squared minus 2x. So it's always coming like a plus 2x or minus 2x. Then I'm going to multiply this to the 2 because it should be 4x, right? So plus what should come is this constant's square, right? So it's going to be 4, 2 in the square. Is it like this one is the same as this one, right? No, this part of this equation, right-hand side part of this equation is bigger than the left-hand side for 4, for this number 4. So because I added this in order to have the complete square of x minus 2 in the square, right? So since I added the 4, I'm going to subtract this 4, so minus 4. Then I can write this as x minus 2 in the square minus 4. So what I'm going to do is I'm just going to substitute this to here. So let's just put it to here. Okay, so it is going to be equal to minus 2 times x minus 2 in the square minus 4 minus 72. If you open up the brackets, it is going to be minus 2 times x minus 2 in the square plus 8 minus 72. If you simplify the terms out, it's going to be minus 2 x minus 2 in the square minus 64. Okay, so if you would write down the parameters, the values of the parameters is going to be a is equal to the minus 2, h is equal to the 2, and k is equal to the minus 64. Okay, so this is how we need to bring a general form of the quadratic equation into this complete square form. So there is a reason why it is important for us. The reason is that it is superbly easy to sketch the graph of the quadratic functions if they are in this form. So let's say you are given the quadratic function and the complete square form. So a times x minus h in the square plus k. So if you would like to sketch this, it is going to be super easy. So it's like you are going to put the rectangular coordinate system with the x and y here. Okay, so the first thing which you need to look here is the sign of the a. Okay, so if the a is positive, then this parabola is going to look like upward. Okay, so it's going to be upward parabola like this if a is positive. Then this minimum point of this parabola, because any parabola is going to go down until some point, then go up, or go up until some point, then go down. Okay, so this minimum point is going to have the coordinates of h and k simply. Okay, so which is already here, so everything is here, so just substitute the numbers, the parameters of this parabola. So what if the a is negative? So as in our last example, so if a is negative, then parabola is going to look downward. Okay, then in this case, if the parabola looks downward, it is going to have the maximum point, not a minimum point, right? And can you guess what is going to be the coordinates of the maximum point? Well, again, it's going to be h and k. Okay, so the sketching the parabola from this form is easy. Okay, so we just need to know a, h, and k. Okay, so we call this form as the upward, and we call this one as the downward. Or we call this like a concave upward, concave downward, right? Okay, so let's do a couple of examples, sketching the quadratic functions from this form. So our last example was minus this one, right? So y is equal to the minus 2, x minus 2 in the square, minus 64, okay? So I would like to roughly sketch the graph of this function. So it's going to be, so this is the x and y, okay? So let me write down first of all the parameters. A is equal to the minus 2, h is equal to the 2, k is equal to the minus 64, right? What does it mean? It means that a is negative. It means that parabola looks downward, right? It is looking like this. Now I need to find its maximum point. The maximum point is going to be here at the 2 and minus 64. So let us assume that minus 64 is somewhere here, okay? So this is going to be the point with the coordinates 2 and minus 64, and the parabola is going to look down, okay? So the parabola is looking roughly like this. So this is not exact graph, okay? So because the broadness of the parabola defines the A, okay? So if A is larger, then it's going to be broad. If the A is smaller, then it's going to be more shrinked, okay? So we're going to talk about this later on. So let's now just talk about how we can roughly draw the parabolas. So let's say you are given like y is equal to the x minus 3 in the square times like 3, for example. So plus 4, okay? So in this case, I'm going to again draw the rectangular coordinate system. This is x and y. So again, so the parameters of this parabola is a is 3, h is 3, k is 4. What does it mean? It means that I need to look to the value of the a, which is positive. It means that it should look upward, okay? Then it should have a minimum point, and the minimum point has the coordinates 3 and 4, h and k, okay? This could be 1, 2, 3 here, 1, 2, 3, 4. So this point is going to be the minimum point, and this parabola is going to look something like this, approximately like this. Okay, so we've learned how to bring a general form of a quadratic function into this complete square form, and we've learned that we need this form because it makes our life much more easier to sketch the graph of the parabolas. So in our next lectures, we're going to discuss how the graph of the parabolas can help us to solve the practical problems.